Welcome to our presentation on building future leaders through data-driven admissions strategies. In today's competitive academic environment, selecting the right candidates is crucial to ensuring not only academic success, but also long-term career outcomes. By leveraging data insights, we can optimize the admissions process to select students with the highest potential for success, both in their studies and in post-graduation job placements. Our project focuses on using predictive modeling to enhance decision making and improve graduate placement outcomes. In this project, our goal is to develop a machine learning model that can accurately predict the post graduation employment status of MBA applicants. This model will allow us to better understand which factors contribute to successful job placement outcomes. The dataset we are working with contains 9 key features, including pre admission information, such as undergraduate grades and work experience, as well as data on MBA performance and employability before and after the program. By analyzing these features, we aim to build a model that helps identify candidates with the highest likelihood of securing employment after graduation. This slide provides an overview of our dataset. We worked with 1,200 total records, and while 4 columns had missing values, we were able to handle them through data imputation. The dataset consists of 3 categorical features and 6 continuous features, giving us a diverse set of variables to analyze and model. Understanding the structure of the data allowed us to effectively prepare it for model development. To address the missing values, the distribution of the columns were checked, and since they mostly showed a left skew, the median of each column was used to impute missing values. However, the missing values in the annual salary column coincided with students that did not get placed in a job 2 months after graduation. Therefore, the missing values for this column were imputed with 0. We analyzed the distribution of students based on their undergraduate degrees to better understand the academic backgrounds of our MBA applicants. The data shows that the distribution is fairly even across different fields of study, such as computer science, engineering, and finance. However, business majors make up the largest group, slightly higher than the others. This diversity in academic backgrounds allows us to explore how different undergraduate fields may influence post-graduation outcomes, particularly in terms of job placement. Student work experience prior to MBA admission was also analyzed. Out of all students in the dataset, only 11% had prior work experience, which indicates that the majority of students are entering the program without professional background. This highlights an important trend where most students may be relying on the MBA program to build employability skills rather than leveraging previous job experience. This chart is a comparison of a student's employability score before being accepted in the MBA program and their employability score after completing the program. The wider range of scores post-graduation shows a significant improvement in employability. This demonstrates the program's positive impact on enhancing students' career prospects. The distribution of placement status 2 months after graduation reveals that nearly 60% of students secured employment. It is definitely a notable achievement for the program. This marks a significant improvement compared to the 11% of students who had work experience before entering the program. The increase highlights the program's effectiveness in preparing students for the job market, contributing to much higher post-graduation placement rates. This result demonstrates the value of the MBA program in enhancing students' employability and boosting their career prospects. The next few slides will focus on identifying the correlation between pre-admission variables and student placement status. These charts display the relationship between undergraduate grades and employability scores with placement outcomes. The flat horizontal line for undergraduate grades indicates no correlation. For employability scores, The slight upward slope suggests a very weak correlation. However, based on the p values, both variables are not statistically significant in relation to placement status. This chart illustrates the relationship between undergraduate degrees and placement status after graduation. The data shows that students with degrees in business, computer science, and finance have significantly higher placement rates compared to those from other fields, such as art and engineering. The p value of less than 0.001 confirms that this correlation is statistically significant, indicating that these degrees are strong predictors of post graduation employment success. This chart explores the relationship between work experience and placement status. Interestingly, students without prior work experience are more likely to secure placements after graduation compared to those with experience. However, it's important to note that the majority of students with work experience also get placed. The p value of less than 0.001 indicates that the correlation between work experience and placement is also statistically significant. For the model development, we used a confidence level of 85% and focused on three key variables: employability before entering the program, undergraduate degree, and work experience. These factors were chosen for their potential impact on post graduation placement. We then tested three machine learning models: decision tree, k nearest neighbor, and logistic regression to identify the most accurate predictor of student placement success. We split the data of 1,200 rows into three sets: 48% for training, 32% for validation, and 20% for testing. To address the imbalance in class distribution, we used the SMOTE technique to balance the data. Additionally, we standardized the dataset for distance-based algorithms like k-nearest neighbor and logistic regression. To optimize the models, we applied hyperparameter tuning first using random search CV, then using those results in grid search CV, ensuring that we identified the best model configurations. For model evaluation, we used a classification report to compare the performance of our three models: decision tree, k nearest neighbor, and logistic regression, using key metrics: accuracy, recall, precision, and F1 score. All models performed well, achieving 96% accuracy. However, both logistic regression and k nearest neighbor outperformed the decision tree in terms of recall and F1 score, with recall reaching 98% and F1 score of 97%. These metrics indicate that logistic regression and k nearest neighbor are better at identifying true positives, making them more reliable models for predicting student placement success. Additionally, we use k-fold cross-validation to evaluate the accuracy of the three models: decision tree, k nearest neighbor, and logistic regression. Each fold splits the data into different subsets for training and validation, ensuring that our model's performance is stable across different samples. As seen in the box plots, logistic regression consistently shows the most stable performance across all k-folds, with minimal variation in accuracy. This suggests that logistic regression is the most reliable model for predicting student placement outcomes. After evaluating the performance of three models: decision tree, k nearest neighbor, and logistic regression, the logistic regression model emerged as the top performer. This conclusion is based on the AUC ROC curve, where logistic regression achieved the highest AUC score of 0.9606, compared to 0.9569 for decision tree and 0.9537 for k nearest neighbor. The higher AUC indicates that the logistic regression model is more effective at distinguishing between students who are likely to be placed after graduation and those who are not. This makes it the most reliable model for predicting student outcomes in this dataset. As we shift our focus to the broader business impact, predictive modeling plays a key role in shaping future leaders. By using data insights, we can improve the admissions process, identifying candidates with the highest potential for success. This data driven approach not only boosts graduate placement outcomes, but also enhances decision making for institutions. With predictive modeling, organizations can more strategically select and nurture top talent, ensuring that the next generation of leaders is equipped for success in the workforce. The core problem we're addressing is whether a data driven approach to MBA candidate selection can be more effective than the current intuition based method. By shifting from intuition to data, our goal is to improve decision making efficiency and increase the likelihood of successful student placements after graduation. With a data driven approach, can we better identify which candidates have the potential to excel and ultimately enhancing both student outcomes and the quality of future leaders? Well, in short, the answer is yes. By using pre admission data, we can apply predictive modeling to identify which students have the highest likelihood of securing job placements after graduation. This shift allows us to rely on data backed insights rather than intuition alone, improving both the admissions process and student placement outcomes. Predictive modeling provides a clear, actionable way to make smarter decisions when selecting candidates. This chart demonstrates that students with prior work experience are far more likely to secure job placements after graduation compared to those without experience. The difference is pretty clear. Students with work experience stand out when it comes to job placement outcomes. This shows that work experience plays a critical role in boosting the likelihood of employment after the MBA program, making it an important consideration in the admissions process to ensure students have the best possible career outcomes. When looking at undergraduate degrees, it's very clear that students with certain degrees have a higher likelihood of being placed in jobs after graduation. In particular, students who studied business, computer science, or finance tend to have stronger placement outcomes. This insight shows the importance of considering academic background during admissions, as these degrees appear to better prepare students for post graduation success. Improving student placement outcomes begins with smarter admissions decisions. By leveraging predictive modeling, we can analyze pre admission data to identify candidates who have the highest potential for post graduation success. Instead of relying solely on traditional metrics or intuition, this data driven approach allows us to admit more students with a higher likelihood of securing a job after graduation. By focusing on students with stronger placement potential, we can not only improve individual outcomes, but also enhance the overall effectiveness of the program, ensuring we prepare future leaders who are best positioned for success in the workforce. Based on our analysis, we have two key recommendations. First, we suggest utilizing predictive modeling in the admissions process to identify and select students with the highest potential for job placement within 2 months after graduation. This approach will allow the admissions team to focus on candidates most likely to succeed in the workforce, leading to better placement outcomes and stronger program performance. Second, it's crucial to continue collecting data on student job placements at different intervals, such as 4, 6, and 12 months after graduation. This ongoing data collection will help refine and improve the predictive model over time, making it more accurate and reliable in the long run. In conclusion, adopting a data driven approach to admissions has the potential to greatly improve both the accuracy and effectiveness of the selection process. By focusing on candidates most likely to succeed, the school can continue to achieve high graduation and employment placement rates. This not only benefits the students, but also positions the institution as a leader in education, trusted by prospective MBA candidates. With improved outcomes, the school strengthens its reputation, ensuring it remains a prestigious and desirable choice for future leaders looking to advance their careers.